With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
There are two current carrying planar coils, each of identical fines and length L. C1 is a circular coil of radius R and C2 is a square of side A. They are so constructed that they have same frequency of oscillation, and when they are placed in the same uniform magnetic field, carry the same current I. So find A in terms of R is the question. So when you see to here, both the coils are rotating. So let's find the angular frequency of both the coils separately, once for C1 and once for C2. Then we shall understand how they are related. So first we shall find it for C1. So for coil C1. So for coil C1, we know that M1 magnetic moment is equal to N1I into A1. And so M1 the magnetic moment and N1 is the number of turns. Here the number of turns, it is a radius, no? So it will be L divided by 2 pi R. And this, when you substitute it over here, you will get it as magnetic moment M1 will be equal to L by 2 pi R is, see, we will substitute it here over that you can understand. See, N1 is L by 2 pi R into I into A1. A1 is how much? It is pi R square. So this becomes pi and R gets cancelled. You will be retained with LIR divided by 2. So this is the magnetic moment of the first one. Next, if I1 is the moment of inertia of the coil C1, then since it is a circular coil, no, I1 is equal to mr square by 2 will be the relation for a circular coil. So omega 1, the angular frequency of this coil, will be equal to root mb by I. So m, we'll write it as m1b by I1. So in this, substituting the values, you will get omega 1, or we shall write it as it is. We shall retain it as it is, call it as 1. Later on we shall substitute it. So now similarly, we will do it for coil C2. So for coil C2, now the C2 is a square coil. That is the only difference you have. So the number of turns per unit length, you can write it as L by 4A, where A is the side. And now here in this, M2 will be equal to N2I into A2. And now here M2 becomes, N2 is L by 4A into I into A. Area of cross section will be side square, which will be A square. So this, when you are simplifying it, you will get it as, see, A gets cancelled over here. So that you will get LIA divided by 4. This is the magnetic moment. Now we will find moment of inertia. Moment of inertia for a square I2 will be equal to MA square by 12. So this we substitute for omega 2. Omega 2 will be equal to root M2 into B by I2. Now call this as equation 2. That is angular frequency. Now what they have told, see, they are moving with the same frequency of oscillation. So I can say it like, in both of these cases, omega 1 will be equal to omega 2. They have same frequency, which means that M1 by I1 will be equal to M2 by I2. Or you can write it as M1 by I1, you will write this as, or you will write that as LIR divided by 2 whole divided by half mr square is equal to M2 is LIA by 4 divided by I2 is MA square by 12. Now we will simplify this. All those things, common things, we will cancel it, we will simplify it, and finally you can write it as Li by Mr is equal to 3 Li by Ma. So Li also gets cancelled over here, M gets cancelled. So you can write it as AR is equal to 3 by A, or you can write it for A is equal to 3R. So this is the relation between A and R which they have asked. See, they have asked find A in terms of R. So A will be equal to 3R is the answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.